would like to open this panel on data center sustainability. So we are all here concerned about data sustainability, and we have great speakers, our panelists. We have heard their presentations. So the question for this panel is, how can I help and how can I contribute? And this is a question for each of us, for an individual and also for an organization. So I would like to start with from a very quick introduction of you. So we have heard about your projects and about your background. But what I would like for you to explain is a little bit about you, your organization, and why are you care about data center sustainability? In order to have a very different perspective, because you're coming from different organizations and representing different actors of the economy in the data center industry.
Do you want to start down there? Alphabetical. How about alphabetical? Astrid. Deborah, Erik.
So I work for Techbuyer, and we are a product life extension specialist. So we would talk about circular economy quite a lot. We've made it part of the way that we do business. So we try and be circular with packaging, with energy use, with everything that's possible. So that's kind of the circular economy side of things. I also work for an organisation called Interact, which was the company that came out of the research that I've just outlined. That looks at energy efficiency. For how can you upgrade machines to make them more efficient? How can you make decisions about refresh for server estates? How do you make decisions about where to locate server estates if you've got multiple locations? Really looking at the energy efficiency side of things. And I also am the chair of the Sustainability Special Interest Group at the Data Center Alliance, which I hate saying every single time just because there's that many words in that title. The reason that I'm saying that is I like to blow my own trumpet, but also because what we try and do in that group is to try and widen the conversation out of just servers. What do we do about the buildings? What do we do about social metrics? What do we do about the global goals? How do we try and make better decisions as a sector? So that's kind of the three hats I'm wearing today.
Well, I've been an academic for a long time, and I really like it. I love teaching, although the students drive me nuts sometimes, but I really miss them if I don't teach. But I also really love research. And in about 2010, I think, a guy called Robert Tozer, who was working for HP at the time, approached the university and said, there's a bit of a problem here. Data centres use a lot of energy, so any nod towards sustainability is focusing on energy use and performance, uninterrupted supply. And I think we need to look at buildings and hardware and so forth. And that was the sort of starting point for me. It really, I suppose I like a challenge, but I particularly like working with the circular economy. I've worked with some really sexy sectors, the commercial refrigeration industry, the solar shading industry, blinds and shutters. I think one of the reasons why I like working with these sectors in the data center industry, they provide amazing services. Just think about access to education, healthcare, etc. The potential for change and change that's already happened. But the back-end stuff, the hidden stuff, is really intriguing, and it's a phenomenal enabler. And from a challenge point of view, we've still got an awfully long way to go. But I think it's the whole system, just taking a systemic approach to challenges has always been a personal interest and a real driver. Do you know, since I started working with the data centre industry, I've met some of the most incredible people. The Sadasi team are absolutely phenomenal. So we do really good research, but we also have a really enjoyable time doing it. And it's been a bit of a sort of dropping a stone into a pool, really. And I met people like Erik and the Open Compute team, etc. And there's just such an enthusiasm and a commitment to trying to bring change. So it can be a bit like teaching students. It can be frustrating, but it can also be incredibly rewarding and enjoyable. And I would really like to make a change. You know, it would be great as a sort of epitaph. She did something good for the whatever industry. Yeah.
So from my perspective, usually quoted as I've been building servers for over 20 years, but in this room, it's probably just over 30 years at this point, right? But so I was involved when I was in school. I've been an engineer, hardware engineer, my entire career. When I was in graduate school, it was the very early days of the internet, right? We were building clusters of machines, right? We hadn't even thought we needed to give it cool names like a cloud, right? We just called it clusters of machines with some few networks combining a few nodes. Then I worked at Seagate for a number of years. I was at Seagate during the early days of the iPod and eventually the iPhone, right? So hard drives made the iPod possible, right? Without the ability to have 10 or 20 gigabytes of data in your pocket, right? I can also tell long stories about the transition from hard drives to flash drives, right? Which was also very, very fun to be part of. But I was always sensitive to this idea that we were building these massive systems, right? One hard drive every 3 seconds, right? I was also, when I was at Seagate, I was responsible for dragging the first salesperson to a little company in Mountain View that had some lava lamps and so on. So that salesperson sold the first hard drives to Google for their search engines, right? Which obviously became a huge industry, and so I've watched us build all of this and all of the clouds and everything out there, and I've always been intrigued by the ability to solve the problems, right? That we were solving a new performance problem. We were enabling this technology. Now we were enabling AI. We were enabling the search, right? All the different things that we've done in between, genome mapping, all those things, high performance computing, et cetera. So we've enabled so much in the society, and we've done it with often massively engineered systems, right? This thing I said about the silos, like it really does take a massive village to make a computing system run. And so the last 3-4 years that I've been able to be involved in more with this sustainability mode, it's just I act as an engineer, right? And there's only one extra constraint, right? Trying to design more with less, right? So in the past, we'd always design more with more, right? And we spend more money, we put more chips, we put more, et cetera. And now we're adding one additional constraint, right? And in many ways, it's really super satisfying to be able to, to create a design or see a design that still has the same ultimate functionality. We thought a little bit harder, thought a little bit more carefully, but we're able to, to do better, in all the dimensions, right? So yeah, that's been my background.
Yeah.
Bless you.
Thank you for sharing that. So this afternoon, we have seen some of your presentations. And we have seen the shift from the closed to open system towards new open business models. And my following question is about the reliability. What can you say about the reliability concerns? Do you find that the closed or old hardware is less reliable?
It's not what the bathtub curve says, and it's not what the returns rates say. So if you look at our returns rates, they are lower than the latest figure, the available figures from the manufacturers. So for us, that's because we line test everything coming in and we line test everything going out. So we've got more extensive testing on each individual bit than other people would do. There are moving parts tend to fail. Fans would fail. PDUs would be, things to fail, and batteries, so we would replace those as a matter of course anyway. So yeah, that would be my answer on that.
Erik, do you have anything to add?
Yeah. Let me just, I'm going to add it kind of in 3 dimensions, right? So the first one is when I worked at EMC, our contracted commitment to customers was a 10-year service life on some product. right? So 10 years was the minimum, right? And we negotiated with suppliers and we made sure there were parts available and all that stuff. So 10 years was the baseline, right? And so the idea of, the servers are redundant after 3 or 4 years, right, just flies in the face of the engineering. The engineering life is easily 10, 12, maybe 15 years, right? I guarantee you there are hard drives on submarines that were made more than 10 years ago. And they're not going to come in. And then the second one, even if there's also more components, right? We've built larger systems, right? But one of the ways that the internet grew and the ways that systems like Google, Amazon, Microsoft, the clouds, and so on, were built with much more redundancy in the software layers. Right? So it used to be, and I did this when I was at EMC, and I'd often debate with my colleagues who would have redundant pathways, they'd have redundant chips and multiple network links and all this stuff. And basically we don't do that anymore. We don't do that in the internet. What we do in the internet is we assume that there's going to be 1,000 servers, maybe 10,000 servers, and at any given time 10 or 15 of them will be offline, and our magic software takes care of all this, right? And so that means that even if we do have maintenance events or occasionally a failure event, that the software is designed to handle this purely because the statistics require it at large scale, right? And then I have a last point that slags off software people, but I won't. I'll save it for another question.
Deborah, do you have anything to add?
I think I'll leave that to the experts because they're more involved in the operation. So
I do have an interesting question for you. So in your presentation, you were talking about the circularity and the design that actually when we design new hardware, we need to think about the circularity in advance. So when an engineer is working on the design of a new hardware solutions or even a data center, how they can start to think about their reusability, about the energy efficiency in advance before actually doing these product designs?
Okay, so in terms of material efficiency rather than energy and so forth, in terms of material efficiency, the best way is to carry out life cycle assessments as part of the design process. Now that can make the design process longer and it can be expensive. But at least by doing that, you can see, if I use X material rather than Y, then it's going to limit potential for recycling or it's going to be less durable. And at the moment, what tends to happen is, one of the reasons why we have a big problem with e-waste, etc., products are designed and they're only evaluated or assessed for their impact and so forth once they're on the shelf. So I think that's a key thing, and that will require education, training, etc. up front. But I think the good thing is that more and more academic institutions and also companies are offering CPD, etc., to enable, for people to upskill and increase their knowledge. But I think, I was just thinking actually, when we're talking about change and how, my comment, the great Albert Einstein quote about not doing the same thing over again, expecting magic to happen, sort of thing. There's a sort of contradiction between the IT industry and particularly the service providers, the apps, etc. Look at the number of disruptive industries that have developed and completely changed the way we do everything. Think about Uber and goodness knows what else. They've disrupted the status quo. Why on earth can't we have why is there such an unwillingness to disrupt the status quo in manufacturing, etc.? And if that happens, then something like learning how to carry out simple or complex life cycle assessments and design for circularity actually become part of the process.
So I do have a lot of questions, but I think I will leave the opportunity for our attendees to ask your questions. So please, if you have questions, we are opening our Q&A, and you can ask questions either for a specific panelist or to all of them. We have one question here, please.
Hi, so I'm Ivy. I work at Viva City. We have IoT devices spread out across the city internationally. And what you're talking about here of thinking about the life cycle of a device is great when you're the one manufacturing it. But for people who are just buying off-the-shelf parts, how can we think about that kind of stuff to integrate sustainability into that product development cycle?
You want me to take that to start off with?
Yeah.
Be a prosumer. My term that I pinched off John Laban over there. There are ways and means that you can influence manufacturers, and it's about your buying decisions. So an example would be vapes. You know, single-use vapes, an awful lot of plastic and an awful lot of electronics in those devices. And there is a viable alternative in a long-term vape. You know, make a decision on the back of that. When you are talking to your supply chain, ask them some questions. They may not have the answers for you right now, but asking the questions gets them thinking about it, and it gets them realizing that if they can answer those questions and their competitors can't, they then have a competitive advantage. So you can influence the future of what happens with the market by the questions that you ask and by your expectations.
Yeah, I would. Deborah, do you want to?
No.
Yeah, so I would say a similar thing that I think I'll just give an example. So 10 years ago, I worked on a project with a standards organization and the US EPA, the Environmental Protection Agency, to talk about more energy efficient servers, right? And what we were told at the time was that customers don't care about energy efficiency, right? And the way that was done is that when marketing sent out surveys to people saying, do you care about, the performance or the energy efficiency or the color of your server, then not enough people ticked the energy efficiency, right? And that comes from, the end seller, not, no one, the consumer not mentioning that, right? Hey, can I, if 5 years from now, or 2 years from now, if I want to put a more powerful CPU on this thing, or if I want to, and then they say, well, I have no idea, right? And if no one asks those questions up the chain, then that information feedback doesn't get to the designers, the product managers who gatekeep who assist the engineers in making adequate decisions, gatekeep the things. That information doesn't get back to those who are doing the design, and then it becomes, the customers don't care. They just want it to be delivered faster, or they want it to cost less, and so on, right? So I think that's probably the first kind of asking the questions, right? And then, of course, thinking about it when, if you're doing a system that is going to last for 10 years, then be cognizant of the fact, are you assuming that you're going to upgrade the hardware twice in the course of 10 years, or are you somehow assuming that these devices that you put down in year one go all the way through, right? And even just thinking about that as you go to deploy them could cause you to make different decisions and different purchasing. So, yeah, definitely ask and...
If you think about consumer, white goods, fridges, washing machines, etc., the directives to show energy consumption, is it an A-star product or an E product or whatever? And why isn't there an equivalent in the data center industry, for example? And it could you could also have not just labeling for energy efficiency, but for embodied materials. And I think one of the things that we're trying to do with the circular data center compass is we are absolutely non-judgmental. What we do is present people with information to make informed decisions. Do you want, if your server is 3 years old, is it going to perform the functions that you want it to perform, or could you just add 2 more whatever components to improve that, rather than being swayed by marketing people who, of course, want you to buy a brand new everything. So I think part of the problem is lack of information, particularly in this sector. And the power of marketing is phenomenal, isn't it? It's eye-watering, really. So labeling, I don't know how technically feasible it would be to label stuff, partly because, the shorter life, although we're saying, Meta are now saying they're going to make servers last for 5 years. Let's see if that happens. But I think it's information, giving people power to choose, and that's prosumerism, really, isn't it? The power to choose.
And also, I don't think it's coincidental. When you look at the legislation on carbon, they're introducing that into the finance sector first. They're hitting the money, and you're a source of the money for your supply chain. So use that power.
Just very briefly, just not to make me cry, but so it actually exists. So there is an EPA Energy Star for data center servers as part of the outgrowth of that effort that we did almost 10 years ago. It's just that nobody usually uses it in practice, right? Because the consumers don't ask, or customers don't ask for it, enterprise customers don't ask for it, the OEMs don't publish it. But the specifications and the methodologies exist, and it's just unfortunately not utilized.
Okay, thank you.
Great.
We had another question there, I think.
I think to some extent you may have answered it. It was the fact that it really seems to be massively not in the vendor's interest to make their servers longer lasting or reusable or any other good decision, which will mean ultimately they sell less servers or fewer servers. And I mean, even the things you're talking about for the customer, there are things where making a greener decision will save you. If you use your server for longer and you make the effort to ask Interact how you should reset your server to use less, to work better for the purpose you're doing. But again, a lot of those things, you're asking that your server provider to do something which may in some instances cost you more. So it's there are some aspects of this that are quite difficult in terms of getting the motivations right. Is there any sort of other pressure that can be brought to bear, I suppose, is the question.
Right.
Do you want to go first?
Okay. Again, something I was just thinking about when Erik was talking. I've got a slide that's, I can't remember the source of information, but the sector is going to grow 300% in the EU based on 2018 figures, 500% globally. So even if you're extending product life, there's still not enough in circulation to account for that additional growth. So I think, maybe in the longer term, OEMs might be extremely worried, to put it politely. But I think within the short term, there's a lot of potential to extend life and to design for circularity and to develop alternative business models. The EU has done masses of research looking at growth in this sector, and something like 4 million jobs. I can't remember whether they've been created or there's the potential to create 4 million jobs in Europe. That includes the UK. We won't mention the B word. But linked to refurbishment, recycling, etc., and the circular economy in general. So again, it's this sort of, I think there's a lot of anxiety around hanging on to what and that people, the industry and OEMs should be a bit braver and think, more laterally. HP are trying to create a completely closed loop for their business and to lease products so that they can then take back and so they're not even going to sell new servers. They're going to sell the equivalent of power by the hour, compute by the nanosecond or whatever it may be. So, I think that, they are beginning to think of different ways of approaching the challenge of service provision. But I'm not sure, and I don't know whether you've got any ideas, whether that is a bit of sort of PR spin on their part, or whether they really are transitioning and changing their business.
I'll steer clear of that particular question. What I would say is that I would flip it, and I started with a car engine. That's what my stepdad did. He was a mechanic. My dad was a computer systems architect, and he worked a lot with pencil and paper. And what that taught me growing up is these are machines, and it's within our control to use them as machines. They are supposed to be there to serve us. Why is it that a large chunk of society have got to a stage where they do what the machine tells them to? Oh, this is obsolete, I better go and throw it out and get a new one. Why? Or there's this software upgrade. I better just pay my subscription and just have that upgrade, inflicted on me. There are ways around that. We don't have to be slaves to the machine. It just requires understanding, it requires collaboration, it requires a little bit of impetus to go out there and find this stuff out. And that's why, I think things like this are really, really important for that, for reminding us who's supposed to be in charge.
Yeah, and I just add one other piece of, I think, positivity to this, that even in my time working for a number of different system integrators, system companies that notionally sell hardware, right? If you look at their profit mix and their revenue mix, but certainly the profitability mix and the margins, those for years have been shifting to software and services and so on. So the hardware is no longer expected, just because of the way that the industry has evolved, to carry the weight of the margins and paying all those stuff, right? And then of course we got Disney and everyone to pay for all of our computers, so that made it even easier. But yeah, if you look at the business models and the revenue mix of many of what used to be hardware companies, they are shifting much more to software and services, which apply almost as well, or basically just as well, about computers that are 6 years in play or 8 years as they are for 3 years.
Yeah. We also have another question.
It's Mark Dancy, OCP. I'm interested to know what you think about the importance of using open source firmware to extend the life of servers. And I'd be interested to know what the panel think about that.
I can start.
Yeah, I mean, you know more about
So it certainly helps. Right, the ability to tinker with the machinery, right, and not have some opaque piece of functionality, it is quite useful, right? It's not an absolute barrier. So we've recertified servers that still have some proprietary software along the lines, because some particular parts of the ecosystem haven't been kind of playing along. But so it can be kind of worked around, but it is much simpler if it's also possible to see all of the code that's running in the systems. And I think it's well proven, before someone comes in and is like, oh, that's security, you're going to ruin our lives, that it's been proven that the security at least is comparable, if not better, in open systems than in closed systems. So I think most of the excuses have gone away. The only excuse that remains of it's hard to publish stuff on the internet isn't a great excuse anymore. So yeah, certainly open source firmware helps. It's not absolutely required in my experience, but it certainly helps and makes a wider range of things possible.
I would agree. From our side, we deal with enterprise servers. So the Eco-Design Directive has been enacted in all EU member states, including the UK, incidentally, because it happened before we initiated the B word. So that means that firmware should be freely available from between 2 and 8 years of manufacture for all new machines. That's all well and good, and that's like the legislators trying to make this possible. But we know that hardware providers are locking down component parts with software, blocking reuse, or they are locking CPUs to a particular manufacturer, which means that your freedom to upgrade and rework the system is diminished, even though the legislation's in your favour. Now, if we all had it open source, then this wouldn't be an issue. But I mean, I don't understand the technical ways around that, so it's easy for me to just say, let's do that.
Yeah, very briefly, for those who were here earlier, so remember Richard said, there's two concerns, right, for your security attack surface, right? Incompetence and the Russians, right? So at the time that I was at Seagate, right, the only other place you could get hard drive firmware that wasn't the hard drive companies was in Russia. Right, and so there were people who literally wanted to make some kind of modification to their to how their hard drive operated, and they're like, "Oh, I downloaded this from some Russian website," and then they were like, "Oh, great."
From a slightly different perspective, when we're developing the design aspect, the eco-design evaluator part of the Compass tool, not only does it have lots of guidelines about modularity, et cetera, types of materials, but there are also things about open source hardware. How long? What is the open source firmware? What is the life of firmware, et cetera? So it's pretty comprehensive, and so we combined information from the EU Circular Economy Action Plan with things like Lot 9, blah blah blah, and other eco-design legislation to make it as comprehensive as possible. Because at the end of the day, if you've got a circular server and your firmware's out of date in 3 years, then forget it. It's got to be a completely holistic approach of coding, software and hardware to really solve the problem of circularity.
Yeah. One question there.
Really interesting stuff again. When you were talking about the circular server, Deborah, you were talking about material mass reduction. So the last time I've heard that talked about is in the context of manufacturers, reducing costs, planned obsolescence as a term they use, right? So are those two things in tension? Is it inevitable that you have to use more materials to have a longer service life?
No, I think an awful lot of the server, the sort of fabric, if you like, it's terribly, terribly, terribly over-engineered. It's sort of bomb-proof, and it doesn't need to be. Sorry, bad choice of word, but you know what I mean. It's seriously over-engineered. So things like reducing wall thickness of the chassis, etc. You can make material savings quite easily. And there's a little bit of and also rationalising the number of components. There are, I can't remember the average number of screws. Our researcher, Christina, she's a big fan of fans and screws. But she was, logging, because we've done matters of disassembly and in product inventories and so forth. And the number, it's bonkers. You go from one model to another produced by the same manufacturer, and all the screw holes are in different places, and their number varies as well. So rationalising things like screws, it may not, you may go from sort of 50 to 10, but it's all of those tiny, tiny little changes add up to really significant change.
So I think we're running out of time. So I would like to thank Astrid, Erik, and Deborah for this very slight, however, very interesting introduction to the sustainability data center economy and how can I contribute. And my last question for you would be, what's your call for action and how can we help?
My call to action is lift the hood. Lift the hood on the mechanics and do everything that you can to encourage other people to do the same thing. Encourage people to try and understand what's going on and make sensible decisions that work for them rather than having those imposed on them by the rate of change.
This is slightly shorter term, I think, but we really, really, really want to find a way to build the prototype server. So if very often people don't know what they want until you show it to them. And simply saying, the OEMs or whoever, they're not going to change until we've got something physical and, can use that as a tool for persuasion. We're a bit stuck. So that would be the first thing, is to get this thing, turn it from beautiful CAD renderings and models into something physical to demonstrate the feasibility.
Yeah, and I would say whenever possible, try to speak against or kind of encourage discussion across the silos, right, that I talked about, right? So I'm in so many audiences where it's like, oh, you're a hardware guy, I got hardware stuff over there, right? And then when I'm with my hardware or my firmware friends, they're like, oh, those software people and their kernels and all their open source. And it's just so much closer together, right? The work that we're actually doing doing, right, when you talk about a Yocto, Yocto is a Linux kernel from a different GitHub than, the real Linux kernel. And occasionally Linus gets really upset about something that has to go in because of Yocto, right? So even Linus is not afraid of his hardware, even though he curses it just as much as some other things. So that's what I would encourage, is not that everyone needs to learn all the depths or, go to year-long computer engineering courses, but don't be afraid of the hardware and the systems. It's not some esoteric, things, and it's not going to zap you if you're a little careful. Oh, in Europe it's worse because of the 220. So in America, the hardware is not going to zap you really hard. Don't be afraid of the hardware, but encourage this cross collaboration and cross thinking, rather than saying, all right, I'm just going to focus on my piece and kind of keep running with my piece, right?
Yeah.
Because that's where a lot of value and a lot of kind of exciting ideas come from cross collaboration.
Yeah, I think the call for action for today will be collaboration in open communities. So thank you so much for this great day, and we'll see you tomorrow.